Hello everyone, here I am again, and here I am still talking about energy. In a previous video, I briefly mentioned the topic of renewable energies as I talked about our infographic, and I must say that it has also had some success. It has been consulted by several people who have given me positive feedback, and I am pleased about this. I had expected to discuss the topic by declining it on various machines, starting with refrigeration systems. I recall when they began using or attempting to use inverters on compressors years ago, and it was an interesting development in the field of machine technology. Let me explain. For some time now, inverters have been used on electric motors in order to be able to regulate the speed of the electric motor and consequently also modulate the necessary power according to the seasonality, let's say, speaking of refrigeration units. Why? It's evident that a refrigerator absorbs maximum energy in summer during the hot period, because when it's hot and I need cold, the refrigerator system must pump at maximum, as I'm explaining to you. During the winter season, I have a lower need for energy to generate cold. Why? Due to the improved efficiency of the condensation system, the water temperature may not increase significantly during the production process, resulting in reduced energy requirements. The study, conducted for a while, focused on regulating fan speed and capacitors using EC motors that are electronically controlled through inverters for efficient operation. What was occurring and what is occurring today? The fan velocity will be modified depending on the surrounding temperature. When it's very hot, the condenser fans go to the maximum. In winter, they obviously modulate and go at a slower speed. The same type of regulation was thought to be applicable to compressors. Why? If I have to size a refrigerator group that must maintain the temperature on pharmaceutical reactors during a delicate processing phase, obviously I design it at the maximum power necessary to perform that cooling function. It is evident that there are a whole series of transients in which the cooling power will not be required at maximum, it will not be required at 100%, but there are a whole series of phases in which maybe the necessary cooling power is 50% compared to the chiller's capacity, 30%, what has always been done in the past. They produced multi-compressor systems with step compressors, and then they ensured the operation of all compressors using 2 compressors out of 4 or 1 compressor out of 4 in machines with 4 circuits. In essence, the use of compressors was being partially divided. Intelligent solution that also allows for standby, spare compressors, in essence, a solution that allows you to work with good energy savings and trying to modulate the power, which however is clearly modulated in steps. That is, if I have a system with 4 compressors, I can have 100%, 75, 50, 25, or 0. Another step was to install tanks, let's call them fly, in order to accumulate chilled water and dampen, so to speak, the loads, peaks, and valleys in what is a hypothetical work diagram with the purpose of mitigating the fluctuations and stabilizing the system. It is clear that such a rule is an outstanding regulation that has the potential to be enhanced. Where is the improvement? In the inverter. If I could modulate the speed of the compressor in order to have the disposal of energy necessary at the moment I need it, it would be ideal. I remember that the first attempts to mount inverters on compressors were unsuccessful because the compressors were volumetric piston compressors. They have a very high starting point, and powered by inverters, they would get stuck. When the inverter provided the minimum speed to the compression, the gas pressure obstructed the rotation of the compressor, preventing it from rotating. Essentially, there were numerous issues. With the introduction of scroll compressors, this problem has undoubtedly disappeared and is no longer a concern. As a result, by using scroll compressors, it is possible to use the inverter, and this is a huge step forward in energy saving, at least for railway groups. There are other energy saving opportunities like pump inverter adjustments to save energy by adjusting pressure. We'll cover it in a future video. Have a good day.